Hey, everybody. So today we are getting into chapter 4, and we're starting with 4.1, part 1 here, which is talking about describing angle pair relationships. Okay, real quick, before we get into this actual lesson here, let's start with a warm-up that reminds us how to kind of deal with bisected angles and whatnot. Before you guys try this on your own, let me remind you of something important. When it's telling us that something is being bisected, it's saying that this ray BD is bisecting angle ABC. Okay, remember when something's bisected, it's cut into two congruent halves. So what they're trying to tell us on this problem is that this angle is equal to this angle. Okay, and that's going to be the equation that you can write out. Okay, so go ahead and show yourself that 9x plus 9 equals 12x minus 3. Solve it for x, and then we'll go from there. Okay, so congruent, remember, just another word for equals. So that's exactly what we can do with these values for these angles. So we can say 9x plus 9 is equal to 12x minus 3. All right, another reason why I wanted to do this warm-up is, just remembering how to solve equations. First thing I notice is we have variables on both sides. Remember, I can bring them all to the left or all to the right. It's my call. I'm going to take this 9x and subtract it over to the right, because I like that that's going to give me a positive number right there. All right, so they're gone on the left. I got a 9. Over here, it looks like I have a 3x, and then bringing down that minus 3. Okay, now I can solve for x. Remember, we deal with what's being added or subtracted first. So this 3 that's being subtracted, let's get rid of it by adding. And it looks like we're getting a 12 equals 3x. Okay, finally, we can get rid of this 3. It's being multiplied, so we'll divide both sides. And it looks like 3 is going to go into 12 4 times. I'm going to get 4 equals x. I'm going to save myself a step. Go ahead and flip them around. X equals 4. Okay, real quick, it's always a good thing to check. Is that what they asked for? Did they just say find x? And on this problem, yes. Okay, but look out. Sometimes they'll say find the measure of, for example, angle ABD, and we would have to plug it in there. But that's not what they asked, so we're good. All right, so yeah, that's a nice little reminder, getting your brain back into dealing with angles. That's kind of where we're at here. So yeah, go ahead and get the title of this lesson. All right, and go ahead and get the first definition we have. Remember, whenever we start a new chapter, a lot of definitions pop up in the first section. So go ahead, copy this, get these two examples, and I'll explain what's going on. All right, so we are talking about complementary angles today. All right, two angles are considered complementary if they have a sum of 90 degrees. All right, so it can be two random angles like these, but we know that 32 plus 58 gives us 90, so these would be considered complementary angles. All right, here's another example. We can see that these two angles, just to kind of highlight them, this one here and this one here, all right, they make a right angle. Again, we know that a right angle is 90 degrees, and that means these two angles would be considered complementary angles. Okay, so if you ever see the word complementary, 90 degrees is what they're talking about. Okay, on the, I guess, other hand, we have a word that's called supplementary. Okay, go ahead and copy this down, and I'll explain what's going on here. Okay, a lot like, complementary angles, it was two angles that added up to 90. Supplementary angles are two angles that add up to 180. All right, and again, it could be two separate angles, like a 45 degree and 134. As long as they add up to 180, they're considered supplementary. All right, the most common way you'll see supplementary angles, and I'll say this all the time, is two angles that make a flat line. You guys remember, that's one of the most important things to remember in this class because it shows up all the time. Okay, so this angle here would be considered supplementary because they add up to 180 degrees. All right, so now with that, I'm going to have you guys try out this practice problem, and it's asking to find the measure of an angle complementary and supplementary to the given angle. So on letter A, if they're giving you a 40-degree angle, what does the measure of the other angle need to be considered a complementary angle? Okay, and then same idea, what does the measure of another angle need to be considered supplementary? All right, and then you can try the same thing on letter B. Okay, go ahead and try this out. All right, so hopefully this, wasn't too weird. It's kind of a strange question, but what they're asking is a pretty simple idea. For two angles to be considered complementary, we know that means they add to 90 degrees. So if one of them is a 40-degree angle, the other one has to be a 50-degree angle, right? Okay, for two angles to be considered supplementary, they need to add to 180. So again, if one of them's 40, to add up to 180, the other one would have to be 140. Right? Adding up to 180. Okay, so that's the idea. Let's try it out with letter B. Okay, if I have an 80, 90-degree angle, another angle would need to be 1 degree for them to be considered complementary, right? 89 plus 1, so 1 degree for that. And sorry, I made them red here. Probably should have just kept it black. Okay, but yeah, those would be considered complementary. They add a 90. If I need two angles that add up to 180, well, if this one's 89, you might be able to do the math in your head. This one would have to be a 91-degree angle for them to add to 180 and be considered supplementary. All right, let's keep moving. Okay, so the next big term on this lesson is vertical angles. All right, go ahead and take a minute here, copy down this slide, very important stuff. All right, so the easiest way to think about vertical angles is that they are angles that are created when two completely straight lines cross one another. All right, and there are two angles that basically mirror one another. So this angle 1 and this angle 2 would be considered vertical angles. All right, here's the big thing about vertical angles. They are congruent, okay? Or in other words, they are equal. And a big thing you're going to see a lot in this class is them giving you one vertical angle. For example, if this was a 40-degree angle right here, and then they would ask you, oh, what is the angle of, what is the measure of angle 1? Well, since they're vertical angles, you would know that this one's also 40 degrees. All right, it's really that simple. It's just remembering what the word vertical angles means and how to identify them. Okay, by the way, angles 3 and 4 would also be considered vertical angles. Okay, they mirror one another and they would also be congruent. Okay, so look out for vertical angles. You'll deal with this stuff all the time. Two straight lines crossing one another. That's what you're looking for. Okay, so with that in mind, let's go ahead and try this example together. Copy it down real quick. We'll do it together. Okay, so this example is asking us to find the measure of angles 1, 2, and 3. Basically, these three missing angles, and they're giving us just the measure of one of them. All right, so here is a few things we know. All right, we just learned about vertical angles. Maybe that's the first thing that popped into your mind. I know that this 30-degree angle and this angle number 2 are vertical angles. That means they are the same measure. They're congruent. So let's just start with that. Let's say, okay, the measure of angle 2 equals also 30 degrees. Okay, and by the way, if you want to ever write that into your problem, just show yourself, okay, this is a 30-degree angle. It might look kind of weird if you don't have different colors, so you don't necessarily have to do that. Okay, here's the question. I know that these two angles are 30-degree angles. How can I find angles 1 and 3? They're vertical angles, but I don't know what either one of them is. Okay, well, this goes back to looking for straight lines. All right, here's what I know. This line right here means that this angle and angle 1 create a flat line, and I know that means they're supplementary, or in other words, they add up to 180 degrees. Okay, so you can probably do the math in your head, or you can subtract it, subtract 30 from 180, but that means angle number 1 would have to be 150 degrees, right? 150 plus 30 would give me 180. So there's angle number 1. So the measure of angle 1 is 150 degrees. Right? And now that I know that this is 150 degrees, I can get angle 3 for free, right? They're vertical angles. It's also going to be 150 degrees. So measure of angle 3, 150. Okay, just by the way, another way I could have figured out that angle 3 was 150 is I could have noticed that this 30-degree angle and angle 3, again, make a flat line. They're supplementary. They add to 180. If that's 30, this has to be 150. Okay, so looking for these patterns, it's really what this lesson's all about. And it's simple, but it's very important because this is bread and butter for geometry. You're going to see this stuff a lot. So start to kind of notice them. Okay. Okay, here is the next word we need to get down is a linear pair. All right, so go ahead and take a minute, copy this, get the top part, and then I'll scroll it in a second. Okay, so let me scroll it down here. All right, get the rest of that. Okay, so a linear pair, we've actually already learned what a linear pair was, is we just didn't know it was called a linear pair. Okay, so it's two adjacent angles are a linear pair if their non-common side makes a straight line. This is a really, really convoluted way of saying it's two angles that make a flat line. Okay, and by the way, when they say adjacent, technically angles are considered adjacent if they share the same vertex and a side length. So let me just kind of break that down real quick. If I'm looking at angle 5 and angle 6, notice they have the same vertex and they also share this side length. That's technically why they're considered adjacent, if you ever see that word adjacent. Okay, but yeah, breaking it down, two angles are a linear pair if they make a flat line. Okay, so here's a little bonus question. Is a linear pair always supplementary? What do you think? Okay, well, I know a linear pair make a flat line, and supplementary angles are two angles that add to 180 degrees. So yes, a linear pair is always supplementary. Okay, so this is, again, mostly if you see the word linear pair in some directions, they're telling you, oh, these are two angles that add to 180. That's kind of it. Okay. So with this one here, I'm going to have you guys go ahead and copy down these problems here, and we're going to kind of go over them together. So copy them, we'll talk it over. Okay, so determine whether the angles are vertical angles, a linear pair, or neither. Okay, we have three options here, and those three only go to each problem. Okay, so real quick on your own, think about it. Starting with letter A, what do you think? Do we have vertical angles, a linear pair, neither? Okay, think about these three problems. Maybe write down what you think. All right, so on letter A here, we're looking at angles 1 and 2. Here's what I notice. These are two angles that make a flat line. Okay, so I know that means they're considered a linear pair. Okay, taking a look at letter B, I notice we have these two angles that are across from one another. So my first question to you is, are these considered a vertical pair? Okay, because they kind of mirror one another, they're across from one another. Okay, but if you guys take a look over at letter C, that's a little bit more obvious. This is a vertical pair. All right, so I know on letter C, those are a vertical pair. I'm kind of skipping over to letter C to make a point on letter B, but let's go ahead and get it. So yeah, these are a vertical pair, or sorry, vertical angles, excuse me. Okay, but why is letter B not considered vertical angles? Well, remember, vertical angles, one of the key things, if I flip back to its definition, is that they must, oops, went a little too far, whoa. Okay, they must be straight lines, two straight lines crossing. And if you guys look at this problem here, these are not straight lines. This one's a straight line, okay, but this one right here goes, and that makes these not a vertical angles. All right, which by the way, vertical angles are congruent, they're equal, and these do not look like they're equal, okay? So just remember that. All right, guys, so that's kind of that with this lesson here. Really important definitions. Hopefully you're feeling more comfortable with them. But yes, refer back to these notes anytime you see these words and you kind of maybe forget. All right, I'll see you guys in class.